I'd like now to move on to the last stages of the season. We've understood how period 1, 2, and 3 set up the stage for a perfectly nice, well-functioning canopy. We had the big question mark, yes, but what about the heat events? That's what we're going to discuss, but really to explain why we are looking at those climatic as well as physiological parameters, I wanted to remind that those are the food quality drivers that we try to guess from what's going to be the final composition at harvest. You see that shoot elongation, that's something that we can monitor during period 2, and if it's fast, the rachis of the cluster can be more elongated, therefore you have less cluster compaction, you have less parasitic pressure, you may also have more yield. So that's why we monitor shoot elongation over period 2. Over period 3, and we are monitoring the positive effect or the negative effect of extreme deficits. But at the same time, in blue, we need to be on the watch because as the plant gets older and older, the footprint of climatic parameters such as vapor pressure deficit and temperature and also nighttime temperature as well as light exposure becomes greater and greater. So light exposure around bloom up until veraison will set the stage for the maximum potential of tannins. So that's why it's important, and that's why when you look at vineyards at different elevation, you see very different numbers in polyphenol because of this footprint of light exposure going from the middle of period 2 to the end of period 3. And then if we look at period 4 and 5, again, we still have the strong footprint of vine water deficit. Once it has set up the stage for food composition, water deficit increases or slows down the rate of volume gain. It also modulates the rate of sugar gain into the fruit, which is what Nicolas is going to speak about in a minute during period 4. And then temperature and VPD have a major effect at speeding up or speeding down the color degradation. We know we peak at the end of the color accumulation at some point, but then the potential of the vineyard to maintain this high or low color is also strongly influenced by temperature. So everything is connected, but hopefully with this streamlined analysis, we can keep in track with what's happening. So now you understand why we are looking at maximum temperature even during period 3. And this is where the picture starts to get a bit more eroded because it doesn't look so good from a microclimatic standpoint regarding the consequences on the fruit. You see that the temperatures are the highest we've been recording. If we look at daily, day after day, what's the maximum temperature? Over the period June 21st, July 21st, which is when we want to enhance moderate water deficit, so moderate is not severe, well, we are in conditions where we have severely limiting climatic parameters. You see with temperature on average in the warmest site above 41 degrees Celsius. So right at the border when greenberry survival is about to fail. And that's in Napa. Over period 4, this period is critical because it's during that period that we have this flow of sugar from the leaves going through the clusters. And heat wave during that, regardless of the duration, it might be a snapshot, it might be a few days heat wave, has a major negative impact at disturbing this flow of sugar. And we will see with Nicolas what it means in practical terms. But in order to give you some hints that this is a solid knowledge, I thought it was interesting to share with you some scientific updates. So from the literature review we've done, I have selected a few papers that I think will give you some backbone to really ponder what's going to be the negative impact of high temperature on ripening. I mentioned the work from Guo because I think it's leading the way right now in terms of how small duration heat event can have very far effect on ripening. First of all, average berry weight and temperature are correlated. So we've been used to hear that water deficit and nitrogen deficit drives the berry weight. Well, now, when we are in a global warming era, we need to understand that temperature will have a very strong footprint regardless of how good you do a job with your management of water and nutrients. And what's also very important is that the duration is not what matters the most. It's a peak value, a little bit like a threshold. If you reach 43 or if you reach 50 Celsius, you know you're done. And the same goes with vapor pressure deficit. So that's why it's important to have a constant monitoring, because you may go to a few hours that are little, or you may just be underneath. You don't know unless you monitor all the time. And another very important paper that has been quoted many times is the one from the Japanese Mori on Cabernet Sauvignon, who clearly showed that you had an exponential decline of color when temperature is above 35 Celsius. Remember this 35 Celsius threshold, because we'll discuss it later on. So that's why we focus on temperature, and those are the guidelines we have in mind when looking at period 3, 4, and 5. But a very interesting work has been undergone by Le Courieux and its team, and it's on Cabernet Sauvignon, and they're trying to predict what's going to be the impact of warmer temperatures and how we can mitigate as winemakers or wine growers their negative impact by manipulating lateral removal to provide more shade and therefore lowering a little bit ambient temperature. So the context is that it's going to be more and more common to observe after fruit set conditions where high temperature will stimulate sugar accumulation rate, but that's going to be at the expense of other qualitative compounds, like all the flavonoids family, alongside with acids, alongside with aroma. And another thing to keep in mind when we are trying to adjust the ratio between leaf area and crop, the source-sink ratio, is that ambient air temperature will also play a role, which means that if you used to believe in the past that you had a magic number for your crop load versus leaf area development ratio, bear in mind that even that will be completely shaken by the occurrence of those frequent heat waves. So that's the context. That's what's currently known. But what the author wanted to understand is how different stages are more or less sensitive to buffer the negative effect of those heat waves. So they applied for 14 days a temperature above ambient that's plus 8 Celsius. And they looked later on at the footprint of these single events, how it carries on up until harvest. And here I'm just going to share with you how a heat wave happening during period 3, so between June 21st, July 21st, has a carryover effect that I think is very relevant with what we've observed in Napa. You see on the top how the author have reported that a heat event, here symbolized in green, induced a delay in the heated treatment, as you can see, in the percentage of coloring. And that has been an observation we've heard over and over in 2017 in Napa. Veraison was delayed. Well, here we have a very strong assessment and a strong data-driven report to think that it's very likely that the heat waves during period 3 induced this delay during period 4 and 5. Not only does it affect the coloration of the berries, it also affects sugar concentration. And in more details, Nicolas is going to discuss that, but you can see also on the bottom graph that the moment in time, the onset, where sugars start to actively loading into the berries is also postponed as a consequence of this heated window occurring during period 3. So lots of carryover effect, and this is why it's very important to have an all-encompassing picture where you're trying to connect the dots by understanding what in the past may cause what you observe right now, which is the sixth take-home message. The scientific results tell us that when applied over period 3, high temperature will delay the onset of veraison and sugar loading. We will discuss after Nicolas how heat during period 4 further disturbs the maturation kinetics. We also learned from this report that heating decreased the anthocyanin content at maturity. So this is a big concern because you might be the best vineyard manager or the best wine grower. When heat temperature hits you, it's something that can negate all your good work. So in practice for Napa, it's very likely that despite the very good conditions for the plant developments setting the stage in period 2 and 3, we are going to observe a degradation of the qualitative potential due to those high temperature. From a vineyard manager standpoint, it means that all the operation involving canopy, such as leaf removal or modifying the microclimate with misters, for instance, will directly affect the ripening dynamics. And from a winemaker standpoint, you need to understand what is the threshold beyond which temperature rise will play against your benefit in terms of flavor degradation and color degradation. And later on, as Federico will discuss, we will see how those high temperature, by degrading the cell wall integrity, will impact your cap management decision.